All right, I don't know where the TA is, it doesn't matter. Okay, well, we're going back to it because we want to get out of here early because it's been a long weekend. So anyway, we're going to do assignment number 2. You're going to have it all done, so you just turn it in. For those people who stay till the end, can actually get their work done. So this is going to be a fun program. I'm going to get your confidence back. If I just scared you in the last section, now we're going to, I know I scared everybody. We're going to get it all back. The last section is a little glimpse about what we're going to do next time I see you. Just in case you go, there's nothing more she could possibly show us. Okay, next time I see you on March 16th and 17th, we start with those examples and we work forward. So at that point, maybe if you've looked at the stuff in the next month, you might be more comfortable with it. But after you get done with this assignment here, you're going to be very comfortable with it. So this one's called dinosaurs. It's a dinosaur theme. The objective is to practice creating and working with classes and derivations of classes. I like dinosaurs because they're kind of fun. And dinosaurs have several different basic characteristics to them. They have a species name, a height, and a weight, and a movement, and a diet. Some of them eat meat, some of them eat vegetables, just like humans. And they also have several basic behaviors. They eat, they move, and they sleep. So let's go create some dinosaurs. I'm going to read only half of it right now. Once we create a base dinosaur, then we're going to create some other dinosaurs. So your assignment is to define and implement a generic dinosaur class. That defines 3 characteristics of behaviors. The behaviors that are very basic, just printing out a line saying something like sleeps, eats, goes to the bathroom. I don't know, you can have your dinosaur do whatever you want. Declare all of the member fields as private. Same thing we did with the last example. And make sure that you have accessors and functions that are all functions for all of the member fields. Those are the setters and the getters. You use the dinosaur class as a base class and then make classes to represent the following. These are going to be 3 inherited classes are going to be done from dinosaur. So let's just start out with dinosaur. So open up Eclipse and we're going to start out and we're going to make Dino. I'm going to call him Dino, D-I-N-O. Same thing as we did before, make a new project though. So hold on one second, I have to wait for my Eclipse to catch up. And I'm going to try and go slow enough. If I'm not going slow enough, just say, hey, slow down. Let me know. Otherwise, I'll have this done in 5 minutes. So let me go slower. I'm going to get rid of this example class because you guys don't want to look at this anymore. It's completely deleted out of here. Okay. File, new, Java project. Oh, let's see. I'm going to call this Dino project because I called the first one temp project. You can call it assignment 1, assignment 2. If you do that, you're not going to remember 2 years from now what that is. So it makes it more sense. Just press finished. You don't have to go through the rest of the project configuration. We're just going to use the default for everything. If you open up the project, you see there's an empty source code directory. Click on the source code directory, source code folder, and we're going to go back up to File, New. This time we're going to put a class in here. We're going to put 2 classes in here just like the temperature. We're going to put Dino in first, and then I'm going to put main in second. So let's do Dino. Select class. And I'm going to actually come and call him with a capital D because I'm creating a class, I-N-O. And I'm going to select public because he's going to be a public class. Next time we're going to play around with abstract, but let's not worry about that right now. So we are going to look at public. I don't need a public static void main because this is not the main. Instead, this is going to be option number 2, the constructors from the superclass. We don't really have them, but I'm just going to put that in there so I can get my default constructor. It kind of gets me started a little bit. You don't actually have to select any of this stuff. And we aren't going to inherit any abstract methods yet. We're going to do that in the next time I see you. So go ahead and press finish. I selected constructors from superclass just for the sake of doing it. Press finish. Wait a few minutes, and you see Dino. And I see Dino with this default auto-generated constructor stub. It's created here. I'm just going to take that out because I don't like looking at that. Now I have Dino, so I'm going to do the same thing now. I'm going to go back. I'm going to click on, or actually I can leave it on Dino, but I have a tendency to just like to click where I want to put it. So I'm going to go back and click on the SRS directory and go back up here, File, New, Class. We're going to put another class in there. This one's going to be called Main. So I'm going to call this one Main. I'll just call it Main. It's easier for me to identify it if I put like main or driver on there. So main, and this time I'm going to click on, I'm going to leave it at public, and I'm going to click on the public static void main and deselect constructors. Main never has constructors in it, so they don't know what you're going to create when you pick these templates. So I'm going to go ahead and press finished. What do I get in finished? I get my main string created for me automatically. I like to go through and pull out this stuff because I don't like looking at it, because I already know what those comments are. I know there's a feature you can turn off the comments, but I hate doing that because then students go, how come I got this stuff in here? And I don't. So I'm trying to keep mine as generic as possible. Hopefully I haven't lost anybody so far. Okay, good. So I'm going to click back on Dino. Make sure you're in Dino. And we can do a couple things right now. I'm going to implement Dino because there's a lot of people that like to create all of them and go, well, I'm going to have 2 more classes. I'm going to have 3 more, actually. I'm going to have 3 different types of dinosaurs. I could put them all in here right now. Or I could just implement Dino and then worry about the other ones later. Let's implement Dino. Let's just put implement Dino, okay, because I have choices. Okay, so the Dino behavior, he's going to have 2 methods. Here's my cheat sheet up here. What's Dino going to have? Base dinosaur class that has behaviors that are realistic for printing and stuff like that. But here we go. We have a name, a species name, a height and a weight, a movement and a diet. So I'm going to leave this kind of selected here. I'm going to go back to Eclipse. So I'm just going to go up here. We know these are all private, by the way. And so because we have characteristics right up here, right above, don't put them inside of the constructor. People try to do that for some reason. When they're looking at a blank piece of paper, it's hard to tell what, but put it in the main class definition. So we're going to go private string. Oh, what are we going to call this private string? Name. And what's wrong with the word string? No, nothing. Okay, good. And then we're going to go private. What else we got? Height. Let's go float for that. Float, height, H-E-I-G-H-T. If I just looked at the screen, I'd probably see it. Then we got private. What else we got? Weight. Oh, let's go float. Integer float. Doesn't really matter, does it? How many pounds? I'm going to go integer just for variety. Weight. And then we got movement. Well, I was going to just call it speed and diet. How's speed and diet work for me? Works good. Speed is really going to be in numbers, so I'm going to go private. And integer, just to keep my life simple. Speed. And then we got the last one here, private. Diet. I'm going to make that a string, actually, because then I can go meat, no meat. Vegetarian, and I can call them, you know, I can say vegetarian, or I can say meat eater, because how do you describe diet? So, string, like a better words here, diet. All of our dinosaurs are going to have these characteristics that are associated with them. And spring, it should be string. String. I'm sorry? String is going to be like words. It's a data type? Yeah, it's a data type. Because string is an object reference, and it has to be capitalized. Just like I created Dino as an object, it's going to be an object type. All objects have capital. Yeah. And then and then all built-in data types are lowercase. So we know in string I can go string dot something. Integer I can't go integer dot anything. It's a primitive data type, where string is an object type. So it takes a hard time to get used to, but I always know it's capitalized because it's object references. Those are always capitalized. That's why I made sure to capitalize the D in Dino, actually. So our default constructor does nothing more than initialize this data, so let's go ahead and initialize it. So we can go this something if we want, or we can just simply We don't have to use this. We can just go like this. We can say all dinosaurs. What is that? All dinosaurs that we create are going to have a name that's going to be equal to. If we don't specify any of this information, I'm going to call this a not set yet. How's that? So the name is going to be equal to not set yet. The height is going to be equal to 0, let's say. You can initialize your data anything you want. I'm going to go weight. Weight is going to be equal to 0. That looks pretty good. Speed is going to be equal to 0. Why do we have to do this? Because if we try to print it out and we try to test for it and it's not set, then we're going to come out with an error. So, what else we got? Speed and diet. Diet is going to be equal to unknown. How's that? Unknown. We don't know what the diet is. And that is our default constructor. And so I'm going to go back here and take a look and say they all should have several basic behaviors: eating, moving, and sleeping. Okay, so I'm going to go back up here. I'm not going to create any more constructors right now. I'm just going to leave the default constructor, and which is okay. And so now back here I'm going to say, what is this? Basic eating. So I'm going to go public eat, public void eat. And so I'm representing this method of this behavior. So this is kind of like method behaviors or messages or behaviors, parts of objects. What do objects do? Well, this guy eats. So let me make this, let me put this up here. I'm going to remember, move, and sleep. Those are the other two. So I'm going to get rid of this console on the bottom so you can see what I'm typing. I'm actually just going to cut and paste this sucker here. So we have eat, move, and sleep. Oops, I thought I pasted it. Paste. Eat, move, sleep. We're good? I know I type fast, so I'm going to start slowing down here. So, what happens when we eat? Now, let's just say arbitrarily every time we eat our weight goes up. How's that? The philosophy of dinosaurs. I don't know anything about dinosaurs. But I'm going to do this. I'm going to go weights plus plus. We're going to get heavy. You know, we just eat, weight. Considering that weight is a factor of, what, 1 point at a time, and weight in this particular example is an integer. And if we weigh 5 pounds, we eat, we're going to weigh 6 pounds, 7 pounds, 8. It's not a realistic world. So, in fact, it just doesn't work the same way for all humans either. And then the moving is what? Moving is going to give me minus, maybe? So we can go weights. Just something happens when we move. Our weight goes down. Exercise. In the world of dinosaurs. It's a minus. You know, we're just making this stuff up. Sleep. Is anything going to happen when we sleep? No, I don't know. Huh? Minus weight? Yeah. Okay, weight minus. Weight minus when we sleep? Yeah. Okay. All right, are we all happy with all these behaviors that we have so far as a base dinosaur? Good. So now let's take a look here. We can create a dino in 1, 2, 3, 4, 5 different constructors that we can create. Can we all see how we can create these dinos? We have a default one here, and I'm going to write one more that's going to take a name and a diet, because we're going to need to set some stuff Otherwise, what we're going to end up having to do is write setters and getters for all this stuff. Does everybody see that? We can write them all right now if we want to. Or we can auto-generate it by using the constructors. Technically, we can make our life simple by just only having 2 variables. We can cut out the rest of it. Or we can do this, and I'll do this right now actually. If we wanted to do this the proper way, we wanted to complete this entire implementation, I'm going to write the function prototypes, and then I'll fill it in when we use it. How's that? So for example, I'm looking at 1, 2, 3, 4, 5 times 5, 25 different combinations of constructors that we could possibly run here. Of the different combinations, taking a name and a height, just the name, just the height, name, height, and weight, name, height, weight, in opposite order, speed, name, weight, and create one with speed, name, weight, name, a diet. All these different things can be put in on the constructors. Or we can write setters and getters, and if we do that, we have 10 setters and getters because we have a set name, get name, set height, get height, set weight, get weight, set speed, get speed. This is the lazy part. So I'm just going to not be lazy, and I'm just going to go ahead and I'll write instead of writing all the constructor combinations, which you can possibly put in, you don't have to. And just the ones you think you're going to use. I'll write the setters and getters because it's only 10 methods. Otherwise it's 25. Yeah, you get it now. 5 times 5. All the different combinations that you could possibly do on all the constructors. Nobody implements those, but I will implement, because I believe that the assignment asked for it. I will implement the setters and the getters, because then those I can reuse. Because these are all private, and unless I write a setter or a getter, I can't get to this. So the reasoning is I'm going to make some setters and getters, because when I inherit, I can't get the weight, but I can set the weight, or I can get the weight from a method. All right, so be prepared. Right now we're going to write 10. I'm going to show you how I'm going to do it. And we're going to do it kind of the easy way of doing it, which is just put them all together. So I'm going to go public, because these are all public. And if I get, I'm going to return. If I set, I'm going to be void, because I'm not returning any. So I'm going to go public void. I'm going to start out with the top one over here, name. I'm going to say get name. Oops, I'm sorry, set name. Set name, and if I'm going to do that, I'm going to take a string on as the parameter, and I'm going to say n as an example, and then I go name is equal to n. That's a setter, and then underneath it I'm going to put the getter, so it's going to be public. Well, what's get? String is going to be the data type. I'm going to return a string, so public string, if I spell it correctly, get name, and then I don't have to return anything, excuse me, I don't have to pass anything on it in arguments. Instead, I'm going to have one line of code that's going to be return name. So that's one set. Some people like to do this because they don't like to look at all this stuff. They do this. And this is called inline functions. Makes it easier to read. That's called an inline, and I'm going to show you that right here too. Because now you know what I'm going to do is I'm going to cut and paste and change all the names and all the data types. So that's a combination of an inline, because it's all in one line, in a line. And it's got all the different, and I'm going to have to make 10 of these, so I figure, well, here's one set. And I'll separate them by space. So here's what I'm going to do. I'm going to see this as cut, or excuse me, copy, paste. And I'm going to get a bunch of error messages, because now I have 2 sets that are identical. But what am I going to look at next? Height. Height's a float. So I'm going to call this one now void. It's always going to be void, right? Void set height. And now I'm going to take in float f over here, float f, and then I'm going to set height to equal f. And now all the error messages went away on that line. And I'm going to do the same thing under here, but height's a float, so I'm going to change string to float. And I'm going to get height this time. And what am I going to get? I'm going to return the height. So this is why I end up putting them together, because now what I'm going to do is just skip a space and go paste. And work for the next one. What's the next one? Weight is an integer. Yeah? And change it automatically. All right. Right click here. Anywhere. Source.
Just 2 steps up. Oh, down. Where come down, more down. Source. More down. Yes. There. Now come to here. There is generate data.
Generate element content. Comment. Oh, comment though. Oh. All right. Well, I haven't invested that much time in Eclipse, obviously. Source. Generate getters and setters. Ah, you guys are way ahead of time here. Select all. Generate setters and getters. I didn't even know that feature existed. Okay. Well, very nice. Very nice. All right. So I actually, did it do what I wanted to do? It did, didn't it? You taught me something new. Okay, so let me try this again. I'm going to remove this stuff up. I'm going to remove all the stuff I put in here. I'm going to remove everything except for my other methods. And instead of doing the setters and getter manually, Eclipse has got a new feature. I've never seen this feature before. So I'm going to go right mouse clicking where I want to put this stuff. And I'm going to go to source. And I'm going to go down to here where it says generate setters and getters. Because it knows what I'm doing. That's excellent. And if I press return on this one, and I select all of them that I want. Actually, it was funny because I had part of them already written, and it only put in the ones I didn't write yet. Oh, look at that. And I select the ones I want. Because it's all the same stuff, right? But they're not making them inline for me, and they put a bunch of spaces in between them. But all of a sudden, they didn't put the spaces in like that, but maybe it was because of the way I had it formatted. So now all my setters and getters are created for me automatically. Wow. I didn't even know that feature existed. And the constructors too. Wow. Well, see, once you know the concepts, then you can automate it yourself. Let's do the constructors next then. Generate all the constructors. It's going to give me 25 of them. I don't know if I want that many. You can select which ones you want. All right, so let's do that. This is excellent. It's not going to do these for me because that's not automated. So actually, I like to put my constructors up here. I'm going to put my constructors underneath my default constructor. And so now I'm going to go and let me try that out. I'm going to right mouse click and go to source. And this is generate constructors from superclass. Now let's just generate constructors using fields. Oh, wow. Let me use all those fields. Let's see what this does. Oh, nice. And it uses the this, and it uses the super. Oh my god. This is programming by click and play. Excuse me? You can?
Yeah. So just right click source. There's a format option. Source. Yeah.
Format. Oh. Well, you guys know all the shortcuts. All right. See, I just, you know what, I don't really use Eclipse except for Android stuff. So I use Xcode most of the time. We don't have those features. Go figure. So, Eclipse is great. All right. But I can't teach you how to, you're not going to learn anything if I teach you how to do it that way. So, but you know what, we already know what we're doing, so we can do it that automated way. All right, so are we all good with Dino? I finished Dino in half the time I thought I was going to take to write Dino. So now, actually, I know there's a way of automating the superclass too. So let's create a superclass of Dino. If you haven't finished Dino yet, go ahead and populate him in with some default constructors and some other stuff. And give him some setters and getters, manually or automatically. And so now we're going to go, I'm going to click on the source code directory again. I'm going to come up to File, and I'm going to go New, and I'm going to go Class. And now I'm going to say, oh, I can't do that. Okay, so now I'm going to create a new class. I thought I could subclass automatically. So now see, the assignment description says to create, that was our base class, by the way. And did it tell us what to do with this? Behavior should be basically just printing out a line saying, oh, we didn't put the line in there. I'll print out the line in a few minutes. Declare all members as private. Okay. All right, so now we're in that. Okay, I'm going to make my life easy and call it an APA, a TRIA, and a HEDRA. So APATA, you can abbreviate your dinosaur types. So in the name here, I'm going to call this one an APA. What was that again? APA something. TO, apto. APATO. APATO. There we go. In, I wonder, I'm half tempted to write Dino in here and see what happens, but I'm not quite sure that's going to make it. You might want to leave that on the defaults, actually. And I messed it up. Well, we'll see what happens when we don't do that. I'm actually kind of experimenting right now. Don't need the public class, but we do want to put constructors in there. If you haven't removed it yet, put this in here. Actually, I'm going to try Dino and see if that actually works. You should be able to subclass Dino this way, but we'll see what happens. Instead of subclassing from object, I wrote Dino in here. I'm going to see what happens. I'm going to press on finish. And yes, it does work. It extends Dino. So we're good with that. Except for down here where we've got a super name. Do I not have that constructor? I don't have that constructor. I probably don't have one that takes on name, height, weight, speed, and diet. So let me go to Dino real quick here and see what happened with Dino. Oh, let me do it again. I have to make 3 of these, so let me do it again. Let's make all 3. So I have apto created, so I'm going to do another one here. You're going to do this 3 times. So I'm going to go class, file, new, class. And then over here, where it says name, I'm putting in Tetra now. What's the next one? Hold on a second. Let me just get my names here. Tyran. Tyran. So Tyran. And what I put here is instead of where it says superclass, java.lang.object, I put in here Dino. Because Dino's our superclass. These are all Dino types. And then down here on the bottom, I selected the constructors from superclass, and I left everything else blank. This is going to generate an error because we don't have a constructor that matches the same footprint. It's trying to run a name, height, weight, speed, diet, but I don't have one in Dino. What do you not get? This is trying to run a constructor in Dino that doesn't exist. I would just pull this line of code out. Are you saying that this doesn't show up on your screen? Oh, so let me try it again. Source code. It's showing up on my screen. This one I'm not going to select it. So I'm going to go class. I have to make one more anyway. This button down here is what's giving that to me. It's selected, but it doesn't do it. Oh, you may not have added any constructors. If you didn't add any constructors to Dino, I'm going to have to go back and add a constructor because I don't have the one that matches that. And I'll just leave this one alone. I'll just go ahead and add that constructor. But what's my third one? Let's see. Hold on. I got to make one more here. HADRO. I'll make this HADRO. I'll do HADRO on this one. HADR. HADR, so HADR, and I'm putting Dino in here, and I'm going to leave this one because it's going to try and copy it from Dino, but Dino doesn't exist. So don't worry if it doesn't, because what ends up happening is you can pull this out. Yes? Can't create what? Oh, hold on one second. Let me take a look. You did not get the constructor? Don't worry about it. If you don't have Dino, if Dino doesn't have a constructor, then you're not going to get it in the superclass either. I have it, but it's the wrong format, so mine's got a little thing on here. If I do this and look at this, it says remove argument to match Dino. Yeah, there's a missing argument in here. So Dino out here, if I look at Dino, I don't have a constructor that matches. I have a string, but I have a name, height, weight, speed, diet. Diet, speed, weight. Oh, I do, which is kind of interesting. So Dino, the automated system here messed me up. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It should be running super. I'm going to create, well, let's take super out of Dino. I don't need super inside of Dino. Well, I do need super. I'll just leave super. Integer, float. Let's see what this message is giving me. String, float, integer, string. Name, height, weight, speed, diet. Constructor, Dino, string, float, integer is undefined. Okay, let me go back to the automated system created my. I'm going to actually do this. I'm going to go like this here. I'm going to copy it so I know what the order is here. And then take a look at Dino. You know what? I didn't save Dino either. Let me save Dino. I saved Dino and all the error messages went away. Because I'm thinking, I already saw it. It's right here. I have it in here. Okay, so some clarification for some people. The first thing you want to do is save something. The autosave hasn't saved it for me. When I saved it, all of a sudden, the messages that were appearing about super went away. If you don't get this line, it means you don't have a constructor defined in Dino. Don't worry about it. You can always write the constructor inside of Dino. This is the constructor here. I'm going to create another constructor for those of you who want to see how to do this automatically. Constructors are not a bad idea. It automates the behavior of the object creation. Otherwise, you have to run all these setters and getters. I'm sorry? Well, if you want to be complete, you have setters and getters, and you have constructors, and you have constructor for every single combination you can possibly imagine. And you have setters and getters for every single piece of data, which is why I believe Eclipse has made it automated. Let me show you a little trick, actually. If you don't have a constructor yet in Dino, open up Dino. I'm going to put a new one right underneath this one. And I'm going to click here. I'm going to right mouse click. And I'm going to go to Source. And I'm going to come down to the bottom where it says Generate Constructors Using Fields. Are we there? Okay, good. And then it's going to allow me to select which one I want. The one I selected by default, selected all. I already have this one, so I'm going to do this one here. And just do one that does no diet. Actually, I'm just going to do one that does diet, maybe. You want one that does all of them. It's a little easier. And then I press OK. And then I have the constructor here for me automatically. And then when we make the class and we put Dino in there to superclass it, we automatically get on the top that apto extends Dino. And we should have Tryan that extends Dino. And then we have, I don't know, header that extends Dino. Are we there? Are we good so far? Okay, we have small groups, so I can wait for people to catch up, or I can also answer questions or solve problems. So we're all good right now. Very good. All right, let's go back to see what we're going to do next. We're going to keep all the behavior that we have. In fact, at this point, I'd like to make an instance of one of these objects and run it and see if we can actually create one of each. Not a bad time to kind of test your methods. So we can make them. And if you haven't made it yet, I'm going to remove this line because I don't like looking at those comments. If we make a new header, if we make a new Tyron, and if we make a new apto, it should also make a dino for us. And the one thing I didn't do that the instructions wanted me to do was to identify when these behaviors were being done. So I'm going to do that right now too, so that when I run this in the main, I have some output. So in the methods here to eat, move, and sleep, I've incremented my behaviors, but now I'm going to put something to the screen. So I'm going to go system.out.println, and I'm going to say that I'm in a dino class. So I'm going to go dino is eating. So I know this is inside of the dino class. I could probably just say dinosaur, because everyone can run this. So every one of my 3 derived classes is going to run this. So I could say dino, or I could come up with a name, and I can print out a name. And if I do that, I can come up here to the name variable. Everybody's got a name. And so here I can go, instead of just saying dino here, I can go name plus is eating. So I can say, well, who's eating? And then I can just cut and paste this. This is what I'm going to do here. And that moving, so I'm going to put here, paste. So-and-so now is moving. I guess I could put a period at the end of this sentence too. There we go. Oops. And then a sleeping. That way I know something happened, actually. So we go paste. This guy now is sleeping. So I have 3 basic behaviors that are defined. I have 3 derived classes from those basic behaviors. Dino. I just created those, I just basically I left the weight plus plus, the weight minus minus and stuff. And I just put in something to give me some mental feedback when I run the method that I know something has happened. Okay, so if I look up here, I notice that I've got, and I just noticed this a few minutes ago, I'm not doing anything, and this is the automated system kind of screwed this up for me actually, because my default constructor isn't going supering back. It's not going to do anything. If I wanted to, I can super over here and then just do this. I can go super in my default constructor. And then I have my derived constructor. So I'm just going to add a super in there, just kind of like how this one did a super to set all this stuff. So I'm going to add a super in here too in each one of these guys. I don't have to. It's just it's just a separate kind of thing, just in case I don't run the constructor for some strange reason, and I make it just a plain one. It's going to go anyway. It's assumed. But run it. Why not? That way I know that the data is going to be initialized. It's going to be It's redundant, but it's a habit actually of mine, so I just put that in there. So now I can come up here and I can say, well, this is interesting. Dino's got a name, a height, a weight, a speed, and a diet. And then Dino, this is the super that's going to run. All this information is going to be set. So I don't have to run this derived one. So let's make some instances of some objects just to make sure everything works. So in main, I'm going to say this. Oh, that's the girl who left her power supply. Hold on one second. Let me pause this video for a second. We're back to dinosaurs, and we lost a few people too when I left. Wow, dropping out like flies. Dinosaurs are fun. What are you talking about? Okay, let's make some instances of dinosaurs. So we're in main, and in the main program here, I'm gonna make a dino first. So I'm gonna go dino space my dino. I'm just gonna go my on everything. Dino is going to be equal to new dino, and I'm just going to run the default constructors. If you want, maybe we won't run the default constructors on the next one. Dino is just a dino. So then I'm going to say APATO, my APATO is going to be equal to new APATO. And this one I'm going to send some parameters to it, and then unfortunately I'm not going to know which parameters I'm going to send until I take a cheat sheet look at the method over here. And I'm just going to cut and paste this over here. It's not runnable code, but it's a cheat sheet to let me know what order to put these parameters in. You have to have the order correct. So the first one, this line of code is a mess, so I'm going to comment it out. This is for my cheating capability, so I can figure out what order to put these in. Name, well, what name is it going to be? So I'm going to call this one here Apto. A-P-A-T-O, comma, height, well, 5. I think is 5 5.2. He's 5'2". He's a short guy. Weight, 150 pounds. I'm sorry? Yeah. Okay, I don't know. Okay, 3,000 pounds. All right, here we go. 3,000 pounds.
Why are we passing a string?
Oh, why are we passing it as a string? You're right. We should be doing that. This is a number. This is a float. That's an integer. That's a float. The first one, the name, I started with, why? Because I started with a name. Don't use, you have to use the right data type that you're passing it, obviously. Thank you. I'm adjusting back in here from the lost and founds department. All right, so weight, speed, multitasking. Speed, how fast are we going to go? What is speed? Is it an integer? I can't remember. 200 miles per hour. And the diet. Diet is a string, I believe. I'm going to put here veggies. Huh? I know, but I'm just going to put veggies. Okay, I have a problem here. Remove arguments to match Apto. Change constructor. Let's take a look at Apto again. String, integer, integer, float, string. String, integer, integer, float, string. Integer. String, integer, integer, I don't know, just keep it like that. But I should have made them all integers. That would have made it easier, I think. Match your data types, please. What we've done is we're making a dino through an aptos, aptopt or whatever. So we can do this with the other ones. I'm actually going to do this here. I'm going to copy and I'm going to paste it here because I want to make 2 more. This one's going to be a HADR, my HADR, yeah? Why? Because we have to go 5.2 F to convert it. So the float number, if we want to put precision, we have to put an F here to cast it to a float because we're not taking we're taking a number that's not really a float. It's actually interpreted as an integer value, but we're putting decimal precision on it. We're converting it to an F. So we're putting an F. Otherwise, we could just use integers and solve that problem. But if you put an F on there, we can get the float to come in. So this is the height. Maybe this guy's 10 feet tall. And I'm going to call this guy HADR. And you can use HADR. There we go. Oops, if I spell it correctly. So I probably should have made it a little bit more intuitive in terms of the naming. This guy is also going to be a veggie guy. HADR. There we go. And one more. Because I want to make sure all of them work. The other one is a T. Oh, this is a good one. So TYRAN. My Tyran. My Tyran. Oops. Tyran. Tyran, I'm going to make him guy. I'm just going to put here meat eater. Meat eater. There we go. I know there's a carnivore and a carnivore. You may use those words if you want, or whatever way you want to describe it. This guy, veggies and meat eater. I should just say here, put here, meat lover. Meat lover. There we go. All right, so we made, I made 1, 2, 3, 4 instances of each one of those objects that I created, but they're all really dinos because we haven't added anything to make those other objects more specific, which is what we're going to do next. But I want to make sure this works at this point. So I can go Hadro dot sleep. What did I call him? Hadro? My Hadro, I'm sorry. My HADR dot sleep. And I'm going to just randomly just pick my TYRAN dot eat. And my, oh, what do we got here? APATO dot, what were the other options? Well, we can come down here and take a look. Move. I haven't done a move yet. I'm just going to run one of each to make sure I have the proper stuff coming out and everything works. So I should get the name of the guy along with whether or not he has slept or ate or moved. So if I come up here and run the project at this point, on the bottom I got Hadro is sleeping, Tyran is eating, and Abdo is moving. It's a nice little test to make sure I'm on the right track. And Dino, I didn't do anything with Dino yet, so I can possibly run Dino if I wanted to. I can go here, my Dino dot, I don't know what we can do. Let's get something. Get diet. But get diet's going to return a string, so I could possibly stick that inside of something. So I can go like this and go system.out.println. And inside of here, I can go Dino likes, and then it's going to say get diet, and then let's see. There we go. So, and I just misspelled println. Print. So now I say Dino likes unknown, which is kind of interesting because it is unknown. We didn't set Dino, I just made a regular constructor for Dino. So if I wanted to out here, I can go my Dino dot set, what was it, set diet. And we're going to set the diet to, we'll set it to meat eater, eat lover. Obviously, when we're using strings like this, we would actually, in the set method, make sure that it was one of the 2 options or the 3 options or something that we wanted it to be set to, which demonstrates a nice point, actually. In the set, for example, and here I ran set diet. In diet, we're just taking whatever got set in and we're assigning it to diet. So I could put something that makes no sense in here at all and say computer science. And then I ran the program, and it said, Dino likes computer science. Well, it's true, but it's not telling me anything about his diet. So I could, maybe perhaps put a couple of choices in there, like veggies or meat liver or however I wanted to do that. But you don't have to do that for this assignment. So this assignment, we're just making it work is all I'm asking for. Have anybody or everybody gotten to this point yet? Okay, good. Yours? Have you seen a couple more minutes? I can hold off for a couple more minutes here. Let me hold off. Actually, here, I'll change computer science back to something like meat. Who's that? Meat lover. How's that? Or hornivorous or carnivorous or something. So that's our Dino. Let me see if I've missed anything in terms of teaching objective. No, not really. Get everything, get name, set name. Main program makes some here. That's good. What we haven't done yet is specialize our classes yet, which is what we're going to next. So when we specialize a class, here's a concept. We essentially have 4 dinosaurs in here, and they're all the same. Although we have superclass, we haven't really changed anything about them. So we can add stuff to the dinosaurs to do something with them to make them more specialized, which is the point. So there should be a difference between the three dinosaurs. So in the assignment, it's going to have you add behaviors to it. I'm going to try and leave this up. I know someone's looking at it, so let me just, oops. Well, let's just click that with it. I'll just cover it for a few minutes here. So I use the dinosaur class as the base class and make classes to represent the following. And this is what we've done. And then for each one of these classes, come up with at least 2 additional pieces of information. So those are going to be data pieces about the specific dinosaur type. For example, Tyrannosaurus, you might have the number of teeth. So teeth is a good idea. That's just an example. Also customize at least one of the sleeping, eating, moving behaviors for each one of the classes. And that means you have to overload a method, because it's not going to be the dinosaur is sleeping, so we're going to have to overload that method so we can make it look different. Well, that means we just write the method again, right? It makes it overloaded. We'll see how that works. And then once you have these, write a small driver program, create one of each of the kind of dinosaurs and have them go through their behaviors. Okay, so for the guy who was still looking at this, I put it back. So now what we're going to do is specialize. So let's add some teeth, hair color, tail, I don't know, anything you might want to, wings, put that wings on your dinosaur, change your dinosaurs around. So I'm going to go into Apto, because that was my first dinosaur here. Up here at the top is when I'm going to add it. So I'm going to work with Aptos right now. I'm going to give him teeth, and it's going to be an integer value to represent the number of teeth that he has. So I'm going to go here, public, private teeth. And teeth is going to be an integer, so private integer teeth with a semicolon. And so now because I have this in my Apto default constructor, if I just create a regular old Aptos, I would want to set the teeth to equal 0 or something. And then down here, super is going to set for me, because all this behavior in the constructors for Dino. Dino is going to set the name, the height, the weight, and the speed and the diet. So now I can go this dot teeth. Teeth is going to be equal to, and then I'm going to, well, where am I going to get teeth from? That's the interesting thing. So now I have to add teeth up here. I'm going to make life simple and just stick it at the end and go here, integer teeth. This constructor does not have to match the constructor in the base class, because what we're doing is we're overriding the constructor. So we're going to call this one, and I'm going to go here and say teeth. So what I did was when I make, and I'm going to go back into main, I'm going to change this now. So I have a teeth that's being passed to it. I added teeth to the constructor of my Apato. I put teeth up here. I could have a get teeth and a set teeth. I could do that. I can come up here and say, I'll use this new method here, source, setters and getters. Here we go, getters and setters, and say teeth. And add in a get teeth and a set teeth in here. And so get teeth returns teeth. Set teeth says this dot teeth is equal to teeth, which is the same as this one here. So if I wanted to, I could actually just do this. Give you another choice. I can run this. Set teeth. And take out this line of code. Oops. Set teeth with a number, teeth. Now I started going fast, so I'll start repeating myself again. These 2 lines of code do the same thing. I only need one of them. So I'm going to go like this with it. I can do it twice if I want. It's not going to cause an error message. But often you'll see if you're going to write the setters and the getters, you're going to call the setters and the getters from the constructors. And that was one of the examples I showed you before I started this one. But in here we added teeth to the constructor. Only works with the apato. We put the teeth in here, and then I'm going to run the set teeth method. Set teeth method is going to set the teeth. The teeth only belongs in here, which means if I try to get the teeth from another dinosaur, I'm going to get an error message because it's not going to include it. So I'm going to go back into main and see if this works. So in my aptos here, all of a sudden it's like, well, you don't have I got a message because you didn't put the teeth on here. So I'm going to put here 50. It's going to have a lot of teeth. So now I have a method that says 50. So how am I going to know it's set though? I can come down here and underneath my apto.move, I'm going to go here, my apto. No, actually I'm going to do system out. I'll just print it out. System.out.println, print line. And I'm going to send in here, it says my apato has plus, and then I'm going to go my apato.getTeeth, get teeth has, oops, I didn't mean to put an equals there, I meant to put a plus here, plus get teeth, has blank space teeth. Everybody see what I did? So I can tell how many teeth this apto has, and I initialized him with 50 up here. I'm printing something out. It says system.out.println my apto has blank teeth. And I have overloaded the constructor. I've overloaded the constructor on this particular instance for this particular class that was derived from Dino, not the rest of them. The rest of them, if I try to put teeth in here, I'm going to come out with an error. But apto has teeth in him. So now if I run it, I should see that he has 50 teeth. My apto has 50 teeth. So that's an example of overloading a constructor. So I'm going to go to my other dinosaurs here, Tyron. I'm going to give him a tail. No, I'm going to give him a number of eyes. I'll do that. Okay, I'll just make it an integer as well. So I'm going to go private integer eyes. So now he now has eyes. So in my default constructor, I'll set eyes is equal to 2 as normal, perhaps, you know, if I don't have anything set, I'm going to give them 2 as default. I can. Back it up till I set private integer teeth, and I set teeth is equal to 0 in my default constructor. I added integer teeth to this constructor. I don't have to send teeth back to super, because super only has these guys in it. I can go this dot teeth is equal to teeth, or I can just run my set teeth. My set teeth is down here. I'll get rid of that output screen so you can see what I'm doing. I'll just let it sit here for a few minutes because I think you're copying it down.
What does that set to?
This set teeth right here sets teeth to teeth. This one is just calling that method. So I'm calling a method inside of the implementation instead of reinventing the wheel. Don't have to, actually. I can just run this guy up here. In fact, I can run them both and they're both going to do the same thing. They're just going to set the teeth to whatever I pass to it on the teeth. So some people like to do this approach right here, because down in here you can say, well, if teeth, well, here's an example.
This looks super.
This is in the current apato. Super is Dino, and Dino has a name, a height, a weight, a speed, a diet. This eye only has teeth, and we have added to it, but he also has weight, height, and stuff.
So this dot teeth then, isn't that super?
No, this is this. This is apto. Dino's this, Dino's this. But this also has, believe it or not, I can do this here. If I wanted to, this is not a good thing to do, but I can also say this dot name is equal to help or something. Let's see what's going to happen here, actually. The field dino.name is not visible. It isn't visible. I'd have to go back to here. It's not visible. In Dino, it's private. If I take protected here, then this is going to work. Because I have to, now it's working. Which actually is a demonstration of the keyword protected. But I don't want to do this. This is why it's protected. I want to use this constructor to set the name. So I really just want to do this. I want to keep this as private. And then they call it supering back. Oops, I misspelled it. Private. That's a good demonstration, actually. I want to keep that as private. And here, I want this to generate an error because I want to super back. If I super back, which is what I'm doing here, supering it back, I'm setting the name here. I don't want to go to this.name because then you're messing around with the integrity of name. And then you're just like, well, what is the name? You can just set it to whatever you want, right? But let Dino control the name. It belongs to Dino. So all Dinos have a name that will abide by the same rules. And then all Aptos have their teeth. And only the Apto class, if it's private, can work with the concept of the teeth. But these are public methods, so if I wanted to, I could set. So in here I can go like this, and I can say set name to name. Well, I don't have to do that. I can go here. Hello there. That will work because set name is a public method inside of Dino. So I can run Dino's public methods inside of Apato if I want to. It's public. So that's a good example, actually, of how do you do. This is interesting. So if I run, let me go out here because this constructor for Apto is now hello there. Is going to be the name of this guy? So let's see what happens. In main, if I run it, it's going to say hello there has 50 teeth. Hello there. Oh, hello there is moving. And then my Apto, because I put it in here. So I could do this instead. I can go my Apto get name. My Apato.get name. And let me put a string in here to concatenate it correctly. I just put a blank space in there so I can. So get name, so I can put a space in between the two outputs. So let's see. Hello there is moving, and hello there has 50 teeth. Well, I put a space in there so we can. I should put in here like has. There we go. Now the output's gonna look better. Hello there has 50 teeth. But that's because I overwrote it. So now what we're gonna do, we just overloaded a constructor. Now let's overload a method. And I'm still gonna play around with Aptos because we want to change the behavior of, let's say for example, sleep. So if we run sleep, let me make sure I'm running it first. I think one of these guys is running it. So I'm going to leave all this stuff here and just add to the bottom here and go my apato.sleep. And that's going to work, actually. And it's going to say my Apato whatever is sleeping. So this is the behavior. Hello there is sleeping. Hello there, okay. Maybe I should take out the hello there, but that's the Apato's new name. Actually, you know what, here, I'll change it here. Apato, instead of hello there, let's change it to my new name. New Apato. New Apato name. Change. There we go. Make it more complicated. So now it looks like this. New Apato name change. Maybe that was too complicated. I'll just change it. I'll just take that line out. Duh. We'll see. We'll just comment this out. And if we comment it out, we're going to not change the name. We're going to have the name in here correctly, Apato now. So, okay. We have a behavior in Dino, and the behavior is called sleeping. And here it is. Moving, here we go, sleeping. Sleeping, a minus, the weight goes down. That's good. And Now if we printed out get weight after we sleep, we should, so if we get the weight, sleep, and then get the weight again, we should see how that works. Let's test that out actually real quick here because some people are still catching up. So I'm going to go here, system out. It's actually not too many lines of code, .print line, and I'm going to put in here get weight. So Apato, okay, so my Apato.get name, plus, so Apato's weight is plus my Apato.get weight. And then I can just do this here, copy it, and put them down here, paste. So I have the before and after weight, so I can see that the method's working. So I'm going to sleep. So I should lose a pound while I'm sleeping. So let's see. Well, I was weighing 3,000 to begin with, so now I'm weighing. You know, I guess somehow I started. Oh, I slipped up here probably. Hardo was sleeping, but anyway, 299, and then now I'm down to 2,998. So looks like I lost weight while I was sleeping. I have 50 teeth. I haven't lost any teeth yet either, so, which is good, I guess. All right, so let's overwrite it so it doesn't say Apato is sleeping. Let's have it say something else. So in order to overwrite it, we just basically rewrite the same method. We regenerate the same method and we replace it. So then we're overwriting it because the other method's no longer going to be in scope anymore. So I'm going to go over to Dino and take a look at what I've got here. I'm going to take this, I'm going to go here, I'm going to go copy, right? And I'm going to come over here to Apato, and I'm going to paste it in here. Get rid of this down here. And obviously it's going to give me some error messages because I just cut and pasted it in. It's going to go, wait, what's that? Well, then we can go this. We can go here and we can go, well, I still want to deduct a weight, right? So I can go set weight to get weight. So then I can do this. I can say, well, let's do this. We'll go set weight. And now what am I going to set it to? This, we can't do that. So we can say, how are we going to do that? Weight. Yeah, get weight minus 1. Oh, there you go, minus minus. How's that? Get weight. Oh, so we can do get weight minus 1. Get rid of this over here. Make it compilable. There we go. That's a good idea. Get weight, set weight. So a lot of people fear, and this is when people come back in and they say, we just need to make it protected. We just need to make it public so we can change it. It's better to do this because then you have more integrity in terms of what you're changing. So I can still change the weight, although I'm not really calling that method. And then down here I can say, well, name, we don't know what name is. This is not going to work, obviously. So I'm going to put in here something else. I'm going to put in here get name if I wanted to. Get name. Get name. Plus is sleeping. What are they going to be sleeping? Is taking a nap. Taking a nap. We're taking a nap. We're not sleeping anymore. Now when I run the method, oops, let's go back to main. Look at that. Pato is taking a nap. Hydro is sleeping. He's running Dino's method. We overrode this one, and he still lost weight. He still went from 290 to 2009, whatever I said it to. I probably should have made the number smaller. And so now he's taking a nap. So we overloaded, we overloaded the constructor. We overwrote the method sleep. Because we have a sleep here. We have a sleep here. It says he's sleeping, and in Aptos, we have another sleep. As long as it looks the same, sleep and sleep, that means the first one's not going to count, the second one's going to count. So let me show you something tricky.
Can we still print sleep from Dino?
Yeah, watch this. This is what I'm going to show you this trick. Okay, this is above and beyond the assignment requirements. So if you're confused at this point, ignore what I'm going to say and continue on your own frame of mind here and forget what I'm going to say here. But we can typecast apto back to a Dino, run a sleep, and then change them back again if we want to use it. This is the only way we can go back because we overwrote Dino's sleep behavior. And now, because he's an apto, so we can go like this and go new, we can go Dino. I'm going to create a Dino from an apto. I'll show you something interesting. Dino, new apto. It's going to be equal to Dino from my apto. So I took and I typecast. I spelled it incorrectly. If I spelled it correctly, it would work. Here we go. I took and created a new apto. Well, this is really what, a new Dino? No, this is an apto Dino. Let's call it an apto Dino. How's that? A Dino apto. He's really a combo, but we're going to treat him like a Dino. This is called upcasting. So now I can go Dino.sleep. Not Dino, excuse me, it's going to be apto Dino. Apto Dino.sleep and put a semicolon at the end of this here. Now, this apto, which was a Dino, excuse me, this new Dino, which was an apto, but now it's a Dino, is going to be sleeping. And he's going to run, this is going to run the Dino because we're treating him like a Dino. So we can go here, and we can run it, and it's going to be saying sleeping. Oh, he's taking a nap. What happened? Apto Dino. Apto Dino. It's not my expected behavior. He should be sleeping like a Dino. I typecast him to a Dino. Dino apto Dino. Not my expected behavior. Let's see. New Dino. My apto. You know what? Say that one more time. Do I have a typo or do I have a logic error? APTO Dino. No, I think I don't have a typo. I think I have a strange thing between languages. You can do this in C++ and you can do this in Objective-C, but I don't think you can do this in Java.
I guess it is should be other way around.
The other way around, taking a Dino and turning him into an apto? No, if you take a Dino and turn him into an apto, you should be able to take an apto and turn him into a Dino by typecasting him this way. You use a Dino data type.
The left-hand side is correct, I guess.
Dino, my apto is my apto. It should have been a version of my apto. I'm thinking that, wait a minute. Let's do this. We have my Dino up here. My Dino is now equal to Dino apto. Dino version of my apto. Let's treat him like a Dino. He's still taking a nap. Sleep should be coming from Dino. Sleeping. It's still coming from Dino, but it's overridden because he's an apto. You know, in other languages, you can typecast it that way and it works. This is interesting. My expected behavior out of this was to have it work like a Dino, but he's been overridden in the apto. His space has been overridden permanently. So they call it hiding, so in other languages you can actually flip like that. That's why I say it's a trick. It's a flip between the identity of the object. Flipping doesn't work in Java, I see. Because I haven't actually, yes, maybe you have an answer to this. Oh, you have a question?
No.
Oh, you're just stretching. Okay. I thought you were going to tell me why it didn't work. That technically I would expect that to work. It works in Objective-C, it works in C.
Even if you do not use casting. We can always create Dino's instance and we can access their mappings.
Correct. Well, see, I can do this as if I had something that was my Dino and I casted this one here. This is a reference. Well, you know why? I wonder if I can go new Dino. No, I can still cast the reference from from an apto to a Dino to an object. I know, but look, the sleep method in the Dino is this, and it's printing this. Oh, am I printing it out wrong? No, I'm my Dino. Oh, if this is a reference, I'm doing a reference to a reference. Ah, that's why. It's the logic that's screwy. I'm doing a reference to a reference instead of a reference to an object. If I did a reference to an object and I said here, Dino, new apto, I'd be creating, or I don't know what, apato. That doesn't really make very much sense, but okay, I'm creating a new apato, but I'm not assigning apato. I'm creating the new apato as a Dino. Let's see. My suspicion is that it's not going to work either. So, in some languages, you can type it cast, but the problem is I overrode that method, and when I overrode it, I don't think I can go backwards with it in Java. Yeah? It's not calling it from the Dino class, though. Excuse me? Oh, system out dot print line test. You think that it's going to run this one? But I changed it to napping, didn't I?
I don't think it's
No, it's not coming from here.
Can you change the...
Not yet set. That's coming from here, but it's running the apato.
Change the main. Put the main.
Mm-hmm.
Change, remove the Dino apato. Change my...
Changes the Dino?
My apato. Mine? Yeah.
the
Yeah, just remove the Dino.
Oh yes, so what I was doing before, you mean? Yeah, but watch this. It's going to print out taking a nap.
Yeah, print out the other lines.
No? That's what I'm trying to tell you. It's not the expected behavior. You'd think it would. It should. I don't know why it's not doing that. Yeah, that's weird. I think it would. It should. In other languages, it does. C++ it does. It's called upcasting. You're turning it in and you're getting the behavior of the previous object. If I wrote the same program in C++, it'd print out sleeping and not taking a nap. But I have a strange feeling that Java has got slightly different rules. It's by reference. I don't know. Long story short, let's not worry about that. It was an experiment that has gone astray. So what you're seeing, though, is a permanent overwriting. We can overload instead of overwriting.
because we added an extra argument to a pattern. Maybe it's because of that.
No, it's because the method is overwritten. We overrode it. We changed it permanently. We can't go backwards to it because we overrode it.
Yeah, that's what I'm trying to say. Like, we are trying to copy my pattern reference
Mm-hmm.
as a Dino on the Dino reference. But Dino reference cannot hold the sixth argument, which is I or T. If we remove T, we can possibly copy.
Mm-mm. I don't think teeth is playing a part in this at all. It's this code is correct. This code is correct. This is an object reference from Dino, and we're taking my apto, which is apto, and we're casting them back to Dino, which would work. However, we're still looking at a memory space that includes my apto, and my apto memory space overrode a method. And the method got overwritten. So I believe overloading, we can go backwards, but I don't think it's going to work with overloading in Java. That's my suspicion, because that surprised me, because I do the same thing in C++ and it works just fine. And what I get is the dino sleep method and not the apato. So this is a true overwriting. When you overwrite, you overwrite. You can't go backwards with it. Question? Okay, good. That was an unplanned detour. I hope it hasn't confused anybody, but it was a nice experiment. I'm learning something today. So you can't, when you overwrite it, you overwrite it. You can't go backwards with it. And here's the apato, and this is what we overwrote. It says it's taking a nap. So even if we change this here, we put in here test, and so if we sleep up here, this is going to change for our Dino. We didn't have anything that printed it out though. So Dino likes me. Oh, here's test. So test got printed in there. So let me see what else is left on this assignment, by the way. I think I put the assignment away. So what we needed to do is you need to, each one of these instances that you're creating, I did this with teeth over here. With apato. So let's say tyrant, I think I was adding some eyes over here, and I said eyes is equal to 2. And then I'm going to go here, I'm going to do the same thing. I'm going to go here and go integer eyes. And then I can do the same thing over here, and I can say, well, what does that mean? You know, over here I can say this dot eyes is equal to eyes. And I can change the eyes here, or I can run and automatically generate some setters and getters, and set eyes and set. And depending upon what object you are, in fact, here, let's just this way here, the tyrant. I'm going to go here and where's it here? Source. I'm going to do some getters and setters, and let's do it for eyes. I'm loving that new feature. So let's set eyes. So let's see out here, I have a tyrant. So let me, well, part of the other problem here is I haven't been saving either. So let me save here. Watch that problem get fixed once I saved it. Probably not. So down here, my tyrant is going to have an issue because I have to give it the number of eyes. So I'm going to say 4. I'm going to give this dinosaur 4 eyes. And then I'm going to add something right underneath the tyrant here, who's a meat lover. And I'm going to say my tyran dot set eyes. And I'm going to give it 10 here. If I try to run, oops, I have misspelled something here. M-Y-T-Y-R-E, and there we go. If I try to do, like say for example, tyrant's got eyes, and apato, we set some teeth. And if I try to do this, if I try to go apato, my apato dot set eyes, I'm going to get an error message. Because apato doesn't have set eyes, it has set teeth. So in here, I have to go set teeth. And here, if I look at the error message here, it's going to tell me that the method set eyes is undefined for the type apato. So each one of these is definitely a specialized version of the other. So if I go here, set teeth, as an example, the 10, that one's going to work because apato's got teeth. And if I run it here, let's see. I don't think the set eyes or set teeth is going to put anything to the screen here. Ooh. Ooh. No, it's nap. No sleep. You know what happens here? Let me. I'm just kind of curious here. Now I'm obsessing on this. Oh, actually, let's just leave my Dino here. I want to see my Dino run. Okay, it does work. My Dino does work. My Dino is sleeping. I'm just doing the test here, so let me get back to my Dino and get rid of this test. Get rid of this thing. I don't need this thing. There's not set yet is sleeping. Apato Dino. Okay. Alright, so what I did here is I added eyes to tyran. I added teeth to apato and add something that you would like to hydra, do the same thing. And then in each one of them, you're supposed to overload something, like I just did. And the way you overload and overwrite is that you, as an example here, I can change sleep to taking a nap, as I did over here. I could possibly call, overload instead of override this method. As an example, if I have one, it can retain it, I can go sleep, keep sleep alone, but change this one to sleep 5, as an example. So this one here, I'm overloading instead of overwriting the apato method here that I originally overwrote, but I want to keep Dino behavior alive, so I'm going to overload it instead. Instead, sleep is going to be integer I. It's going to be taken in on sleep. And then in here, I'm going to say wait, because I is going to be like sleep for the number of hours to sleep. And then here I'm going to go, instead of saying 1, I'm going to put in I, minus I. So now I've changed this method here, and I've said sleep, and its sleep method now takes on a parameter, and it's an integer value. So out in main, if I save everything, I have to update it here. Save all. Out in main, if I run the apato sleep, where's my apato sleep? Here it is. Apato move, my apato sleep. I have 2 options now because I overloaded it. I can run here my apato dot, instead of sleeping with no parameter, I can say, oops, sleep. Let's send it 500. Ooh, I'm going to get negative weight. I'll just put here 2 in here. So now I have a new method that I can run. In apato, instead of overwriting, which means using the same method that was just sleep, and now I should have both of them back now. Then what I'm going to here is have sleep 2, which is the new method I overrode. So I have both. If I overload, I have both methods now. I have one sleep that just prints out you're sleeping, and I have another one, sleep 2, that's going to print out you're taking a nap. And so now down here, this one will print out the original because I haven't overloaded it. So, long story short, I'm sleeping, and now I'm taking a nap. I took out the overloading. Instead, I overloaded it instead of overwriting it. So instead of completely erasing it with this new function that's taking a nap, I made a new one and I put 2 as a parameter in here. So now actually I lost more weight when I did that because I subtracted 2, which is I, instead of subtracting just 1. But you see, this is the behavior I was expecting initially, taking a nap and then sleeping. Because I did this here, I typecast him back. See, apato is doing both. He's taking a nap and he's sleeping, but one of them's a dino and the other one's a apato, but they're both the same object, if that makes any sense.
So casting started working?
When I took away the overloading, it did. Excuse me, overwriting. I confuse the 2 words all the time. I should just say overwrite and overload. Overloading complements and adds another method, so you have both methods available. Overwriting or overriding replaces the original with a new one. And apparently in Java, once you replace it, it's replaced. And the first one is hidden. The second one is now available. And apparently even with casting, from what the experiment I just did, I have to go home and kind of research that a little bit and see why that's the case. But in other languages, you can get both versions. It doesn't just because you overwrote it, doesn't overwrite it permanently. But in Java, it appears to be writing it permanently. So, but hopefully by this discussion and by seeing these examples, it kind of reinforces the concept maybe of there's a big difference between overloading and overwriting. And we overload operators, we can also overwrite operators, which means we can change, operators as well, I was meaning constructors. We can overwrite constructors so that the initial constructor outside of the default and just leave a blank doesn't do anything. So that's how we get our objects to morph and to change and to turn into things. This, believe it or not, outside of adding something to header, which we could add, I added, let's see, we have Dino's done, main's done. Well, outside of a few cosmetic things. But Apto's done, he's got teeth. Tyran's got eyes. Let's see, I overrode Aptos' sleep method. Well, I changed it again, and now we have one that's over. Oh, I think I lost my audio again. I think somebody's telling me I'm done. So my audio is gone. All right, so what I was trying to do is summarize this assignment for you and tell you that it's practically written already. All you have to do now is add some more behaviors. So for example, this apato here, I overloaded sleep and created a new sleep. I can also do in here, I can say, well, what if a pato likes to jump? So I can go public void jump. And I'm adding a new behavior to this guy here. And I'm going to put in an opening and closing bracket set. And what I'm going to have come to the screen, if I spell this correctly, is something that's going to do system out. So this is how you're going to get your dinosaurs to do stuff. We're going to go system out dot print line. Print line. Oh, what's wrong here? There we go. And I'm going to get the name, let's say get name. And then it's going to be added to is now jumping. And I'll fix my typo here. What's wrong with my typo? Print. A little extra I in there. And so now I can come back out here to main, and what is this? This is an apato, so I can run jump on him. And then down here on the bottom, I'll just add him to the bottom of the screen so we can see this. My apato.jump. I've added a new behavior to the apato that doesn't belong to any of the other ones. When I run it, I'm going to see is not jumping. I misspelled jumping and I put not. So if I come back to apato, I say, what is this? Is jumping. There we go. But I got the correct output. Jump. Jumping. There we go. So I can kind of see how I've customized this behavior. So what you want to do to finish up this assignment, which is really simple actually. In fact, you're probably going to be farther ahead on this one than you were on the previous one, perhaps, depending upon how you figured out the logic of converting temperatures, or comparing temperatures, I should say. Add some variables, change the constructor so you can initialize the variables, pass the information back and forth so you can figure out how to overload constructors. Add some new functions, add some new methods to your derived classes, see what happens, experiment with it. Example here, if I go down here and say my Dino, I'm going to get an error message because that's not going to work because my Dino doesn't know anything about jumping. It's only something, in fact, none of the other ones know anything about jumping either, for that matter. It has to be a pato here. Make each one of them different, zip it up, send it to me, and you're done. That's the second assignment. So you have an entire month. You have until, and I'm kind of doing my wind down right now, you have until the next time we meet. We're not going to meet again until March 16th and 17th. Yeah, St. Patrick's Day weekend, you'll remember that. And then we're going to hit a little bit more with inheritance. We're going to hit interfaces and abstract classes. We've done a little bit with that. More use with practice with using more and more classes. More sample projects. I'm going to try and hopefully arrange it so that I'm not talking the entire time and you're doing more hands-on stuff, but I have to teach you some basics before we can get to that point. So the beginning is normally, if this were a traditional style course and it was running 5 or 6 weeks or so, I talk a little bit in the beginning and then we can, basically arrange it so that you don't have to listen to me, you can just do work the entire time. But you have to know what you're doing first. And then the next time we meet on April 20th and 21st, we're going to apply both weekend skills together. And so we'll be hopefully creating some sophisticated projects maybe, but don't worry about it. It's all in baby steps. Questions, comments, or concerns? So it's much better with the mic. I can't even hear myself when I talk. Well, it is about 5:19. I'm going to hang around till 6, but I'm going to assume you guys have had enough. You guys want more? I can give you more. Certainly give you more. You have a question?
On what basis you will be creating the codes?
I'm looking for a couple things. I'm looking to see if you've got Dino here. Your code can look exactly like mine if you want. I'm looking to see if you have Dino, if you have example main, and you have 3 more dinosaurs, and you're adding some variables, and you're adding some methods or overloading methods. Changing the behaviors. All you have to do is change something about each one of the inherited dinosaurs. For the first one, you can turn in exactly what you wrote in class. This one you can turn in exactly what you wrote in class. I know what mine looks like. I know what I wrote during the weekend. I know what other versions of this look like that I've written at other times. You know, I can tell if it's been plagiarized for the most part. If it matches everybody else's because you all wrote the same thing, that's fine. As long as it matches what I did in class, that's fine. But, you know, cheating is cheating. If you want to cheat on it, you're only cheating yourself anyway. If you look at it, if I look at it, you're going to get 100% on it. If it looks like you were here and you did it, you know. I'm not going to nitpick it. You're going to get full credit for it. So it's not like I'm going to take off points because you misspelled Tyrannosaurus or something like that, or I don't know, got the concept wrong. And, you know, it's kind of like the effort you put in is the effort you're going to get out. You can do absolutely nothing if you want between now and the next time I see you. That's fine. I don't care. But the next time it's going to make it harder for you, I think. So if you kind of keep up, because you know what ends up happening is you're going to leave this weekend. And then next week, you're going to forget all about Java. A month's going to go by. You're going to go, Java? Have we learned about Java? What's this thing? And you're going to forget everything. It's like doing math. You're going to forget everything. So that's why I say get a book. You know, and in your leisure, take a look at chapter 1, chapter 2, and just start looking at it more and more. And then it'll stick with you longer. And then you'll remember more. And then you'll be able to learn more next time I see you. Yeah?
If you upload just the Java files?
All they want is the .java files, correct? If you're going to upload it to the system, you have to zip them together because you can only upload one file. They don't have it so you can upload multiple stuff. You can only upload one zip file. You can tar it, zip it, Z it, 7 it, anything you want to it. I read all formats. You can also catch me by email, bhecker@itu.edu. You can send me your source code and you can say, hey, this is not working. Or you can also go and say, hey, I tried this example in Deedle and Deedle text, and it's this hello world thing or whatever, and it's not working. I'm actually pretty good usually. I can fix it like within a couple, or if I can't fix it easily, I can tell you what's wrong with it at least, and then I send it back to you. Really responsive by email, so that's pretty good. So, any other questions?
In that case, do you still email you the .java file, or do you want your text?
No, if you're an IT student, which I believe you are, you have to upload it into the EMS. Oh, if you have a question, send me the file as an attachment. I have a lot of people that like to cut and paste it and put it into the email message. It's hard for me to compile it because first thing I'm going to do is load it into a project and let the compiler tell me what's wrong with it and then go from there. Otherwise, I'm just going to look at it and go, I have no idea what's going on with this code. Nothing's marked in this code. So it's easier for me. Also, it's easier for me when you submit the assignment. I've had some students take the assignments, take the Java files and cut and paste them and put them into Word files. Why are you even doing that? Don't do that. Some people do that. It's like instead of just zipping together all of them together it's easier for me, easier for you when I look at it if it's not in a Word file. So. Any other questions? Then we're done. I'm going to hang around and answer individual questions and give you help with anyone who's still struggling with any part of this particular program. But I'm going to stop the video. Thank you. See you next time.